Have you ever, stared at your computer screen during its third forced automated update of the week?
Oh, yeah. Watching that little spinning wheel.
Right, and you're just wondering, what is actually going on under the hood?
Yeah, because you are completely locked out of your own machine.
Exactly. While some invisible algorithm just does, whatever it decides is best for you, it's this really frustrating loss of agency.
It absolutely is.
Well, today's deep dive is an exclusive sneak peek at an upcoming release that tackles that exact frustration head on.
It's a really exciting one.
Yeah, we got early access to some fascinating materials. So we have an article and a rather revealing promotional studio image from Season 1, Episode 6 of the One Shot Computer Science podcast.
Which doesn't even drop until June 30, 2026.
Right. So we're getting a major head start here. And our mission today is to explore a system that intentionally stops the clock on modern automation.
A total reversal of current trends.
We are talking about Slackware GNU Linux. It's the oldest surviving Linux distribution in the world, and we're going to see why doing things the manual, painstakingly hard way might actually be, well, the ultimate shortcut to mastering your technology.
It really represents a fascinating counter-movement. I mean, while the rest of the tech world has spent the last 3 decades racing toward total automation.
Oh, absolutely.
Hiding the file system, abstracting the dependencies, siloing the boot process behind binary blobs, Slackware just essentially planted its feet and refused to move.
They just said, no thanks.
Exactly. It prioritizes total architectural transparency and absolute administrator control above literally any modern concept of convenience.
Which is wild, but that stubborn refusal to automate actually makes perfect sense when you look at what the creator, Patrick Volkerding, was dealing with back in 1993.
Yeah, he was in a very different environment.
Right, he wasn't trying to build a frictionless consumer product. He was working with one of the very first Linux distributions available, the soft landing Linux system, or SLS.
Right, SLS.
And according to our sources, SLS was just a buggy, poorly maintained mess.
Oh, it was notoriously difficult to work with.
Volkerding got so frustrated that he started heavily modifying it and fixing it just for his own personal use and, for the professors at his university.
Yeah, he basically had to overhaul the entire architecture just to make it usable.
Wow.
And when he finally released his cleaned-up version to the public, he actually called it Slackware as a lighthearted joke.
A joke that survived over 30 years.
Right. It was just a side project. The longevity of the project, the fact that it survived decades while thousands of other distributions vanished, is entirely due to its rigid adherence to the traditional Unix philosophy.
The KISS principle, right. Keep it simple, stupid.
Exactly. Keep it simple, stupid.
Okay, let's unpack this. Because simple is a notoriously loaded word in computing.
Oh, definitely.
Right. Because when a mainstream tech company says simple, they mean a smartphone with one button where the underlying file system is entirely hidden from you.
Just tap the glass.
Right. You tap glass and magic happens. Modern operating systems are like a brand new car with a sealed engine hood. You can't even see the spark plugs, you just have to trust the manufacturer.
That's a great way to look at it.
But Slackware sounds like a classic car, where you are handed a wrench and expected to torque every single bolt yourself. So doesn't this simple design actually mean it's incredibly complicated for a human being to use?
Well, see, the Slackware community draws a very hard line between system simplicity and user convenience.
Oh, okay.
They are entirely focused on the system architecture itself.
Let's look at the initialization process to
Yeah.
see how this plays out mechanically.
Okay, yeah.
Over the last decade or so, the broader Linux ecosystem almost universally adopted systemed.
Right, which is pretty standard now.
Yeah, but it's a highly complex parallel booting initialization system. It manages background services, socket activations, logging all through this really dense network of binary files.
And Slackware said no. Slackware actively rejected systemed. They chose to remain independent and stuck with predictable sysfinite and BSD-style startup scripts.
So instead of a monolithic binary managing the whole boot process, you're literally just dealing with sequential shell scripts.
Yes, which fundamentally changes the debugging experience.
How so?
Well, imagine a production server goes down at 2 binary. With a heavily abstracted system, you might just get a cryptic binary journal error.
Which is a nightmare.
Total nightmare.
Ugh.
But with Slackware sysfinite, the startup process is literally just plain text files sitting in the etc.c.d directory.
Wait, really? Just text files?
Just text files.
Yeah.
If you want to know exactly how your machine initializes its network interfaces, you open a text file in your terminal and you just read the bash commands line by line.
That's incredible.
There are no hid registries. The system executes the text file from top to bottom. It does exactly what you tell it to do, and nothing more.
And it delivers what they call vanilla software, meaning the upstream source code hasn't been heavily patched or customized by the distribution maintainers to fit some proprietary ecosystem.
Exactly. It's pure upstream code.
So keeping with the car analogy, the classic car isn't hiding any custom wiring harnesses behind plastic panels. The wiring is totally traceable.
Yep, you can see every single wire.
But the trade-off is that you actually have to know how to connect those wires yourself, because that classic car mentality hits you the very second you boot up the installation media.
Oh, it really does.
Yeah, you aren't greeted by a beautiful graphical desktop environment with some automated setup wizard.
Not at all. You are greeted by a blinking text cursor and a raw command line environment.
Which is terrifying for a lot of people.
Oh, totally. The installation process demands that you actively participate in building the foundation of your system.
Right.
You cannot just click a little pie chart to format your storage. The very first thing you have to do is manually partition your hard drive using command line tools like cfdisk or cjdisk.
Manually. So you are literally writing partition tables directly to the disk sectors.
By hand, yes.
You have to calculate how much swap space you need, map out your root directory, and actually assign the hex codes for the file system types before the installer will even acknowledge your drive exists.
It's an intense filter for casual users, for sure.
I'll say. But once you finally format the disk and launch the setup command, you get this menu-driven interface called an incursus installer.
Yeah, and Cursus is actually brilliant for this specific use case.
Why is that?
Well, it's a programming library that generates text-based user interfaces directly in the terminal. So think of those old blue screens and gray boxes that you navigate entirely with your keyboard arrows.
Well, like DOS almost.
Yeah, sort of like that. It doesn't require an X-Display server or Wayland to be running,
Gotcha.
which makes it incredibly lightweight and virtually immune to the graphical crashing issues that sometimes plague modern graphical installers.
That makes a lot of sense. And during this incursus setup, the software you are selecting to install is grouped into alphabetical series, right?
That's right.
Like A is the base system,
Right.
N is networking, X is the graphical base. But this brings us to a massive paradox in the source materials.
Oh, the installation recommendation.
Yes, the official recommendation for new users is to do a full install. They explicitly tell you to select every single software series and install gigabytes of packages.
It seems contradictory, right?
Totally. Why on earth would an operating system built around minimalism and the KISS principle explicitly tell you to bloat your hard drive with software you might not even need?
What's fascinating here is that this full install recommendation is actually a mathematically necessary workaround for Slackware's most defining characteristic.
Which is?
It completely lacks automated dependency resolution.
Wait, no automated dependency resolution?
None!
So if I want to install a simple media player or like a web browser, the native package manager won't automatically scan the repositories and grab the 5 different audio codecs, the video drivers, and the encryption libraries that the browser needs to function. It just fails.
Well, it won't even warn you.
Are you serious?
I am. It will simply unpack the requested software, and when you try to run it, it will just crash because the underlying shared libraries are missing.
Wow.
So by doing a full install of the official Slackware tree, you guarantee that every core library, compiler, and dependency is already present on the local file system.
Ah, I see.
You are basically front-loading the entire toolkit. It completely eliminates the risk of having a broken, unbootable environment right out of the box because all those foundational pieces are already interlocked and tested by the maintainers.
Okay, so you're basically stocking the entire garage with tools so you don't reach for a specific wrench later and find an empty drawer. Okay, that makes sense. So you format the drive, you do the full install, you manually configure your bootloader. So writing the configuration files for Lilo, eLilo, or grep, so the kernel actually knows where to boot from, and you finally reach a working operating system.
You made it.
Yeah, but eventually you are going to want to grow the system with third-party software.
Which is where the real administrative discipline comes into play.
Right.
Slackware provides 2 primary native tools for this. You have PKG Tool, which is a local utility to view or remove packages already on your drive,
Okay.
and Slack PKG, which syncs with official network mirrors to download updates and apply security patches to the base system.
But neither of those will go hunt down the dependency tree for a piece of third-party software, right?
Correct.
So if I want to install a complex open-source video editor, I'm doing the hunting.
You are manually mapping the dependency tree.
Mm-hmm.
You must track down the required libraries, download their source code, compile them, and install them in the correct sequential order before you can even attempt to compile the main video editor.
Here's where it gets really interesting because I have an analogy for this.
Oh, let's hear it.
So using a modern package manager like apt on Debian is like having a personal chef. You say, I want lasagna, and the chef goes to the store, buys the pasta, the sauce, the cheese, comes back, cooks it, and puts it right on your plate.
Right. Highly convenient.
Exactly. But Slackware is like being handed a recipe card for lasagna, but before you can eat, you have to go plow a field, plant wheat, harvest it, mill the flour, and like raise a cow for the cheese. You are farming your own ingredients.
That is painfully accurate.
Yeah.
And that farming process forces a level of systemic awareness that automated package managers completely bypass.
How so?
Well, when you manually compile your own dependencies, you know exactly what is running on your machine. More importantly, it prevents the automated chef from making a disastrous substitution in the kitchen.
Oh, like breaking the system during an update.
Exactly. In automated systems, a routine update might decide to replace a core system library, like glip, just because one new application requested a newer version. That single automated swap can inadvertently break 5 other mission-critical applications that relied on the older library architecture.
Oh, it's the classic Ubuntu upgrade horror story, where you run an update command and suddenly your entire graphical desktop gets uninstalled because of a dependency conflict.
Precisely. By removing the automation, Slackware achieves legendary long-term stability.
That makes total sense.
A properly configured Slackware server can run reliably for literally years because the package manager lacks the authority to make sweeping, system-altering decisions without the administrator manually executing them.
Okay, but the community isn't entirely masochistic, right? Because they did engineer a middle ground solution for all this manual compiling, which our sources highlight. The Slack builds repository.
Yes, the Slack builds project is just a massive standardized community effort.
It saves a lot of time.
It really does. Instead of forcing you...
Okay, so a Slack build is less like a software package and more like an automated factory blueprint.
Right.
You download the blueprint, and it tells your computer exactly how to download the raw source code from the original developer, configure the make file for your specific hardware architecture, compile the binaries, and neatly wrap the finished product into a standard .txt Slackware package that you can manage with PKG tool.
That is an excellent way to conceptualize it, yeah.
But you still have to resolve dependencies.
You do. You still have to run the Slack build for the required library and install it before you run the Slack build for the application.
Right.
But it vastly simplifies the integration of complex third-party software without polluting the purity of your base system with untracked files.
Which really brings us to the real educational crucible of this deep dive.
The learning curve.
Exactly. This deliberate friction, the manual partitioning, editing text configurations in Vim just to get your network running, farming your own dependencies with Slack builds. It transforms a passive computer user into an active systems engineer.
It absolutely forces you to learn.
Our source article actually references a famous adage in the free software community. It goes, when you learn Debian, you learn Debian. When you learn Slackware, you learn Linux.
And it's a profound distinction. Because you lack a graphical control panel, you are forced to interact with the raw components.
You can't just click a box.
No. You learn how a display server actually talks to the kernel. You learn how user permissions are structured in the etc Word file, and how network interfaces are brought up and down via shell scripts.
Wow.
You naturally just begin to read and write bash scripts as part of your daily workflow simply to maintain the system.
And the sources heavily lean into comparisons with other advanced Linux distributions to establish exactly where Slackware sits in this ecosystem.
Yeah, the comparisons are really helpful.
Let's walk through those because they really illuminate the whole philosophy. First, we have Debian. We know Debian relies on apt to brilliantly automate dependency resolution.
Right, it's the ultimate convenience.
But it completely abstracts the foundational mechanics away from the administrator.
Exactly. Then you have Arch Linux.
Arch is huge right now.
It is. And Arch shares Slackware's minimalist command line-centric installation philosophy. But their release models are polar opposites.
Because Arch updates constantly, right?
Right. Arch is a rolling release. It is constantly pulling the absolute newest, bleeding-edge software updates from upstream. This gives you the latest features, but running a full system update can occasionally introduce system-breaking bugs.
That sounds risky.
It can be. But Slackware operates on static, stable releases. The core system remains completely frozen for years, receiving only critical security patches.
So it's much safer.
Much safer. It ensures maximum reliability for production environments.
Next on the list is Gen 2. Gen 2 takes the manual compiling aspect to the absolute extreme.
Oh, yes.
You use their emerge tool to compile almost everything, including the base system itself, from raw source code using specific USE flags so you can optimize the binaries perfectly for your exact CPU architecture.
Takes forever.
Right, so Slackware saves you literally days of compile time by giving you a pre-compiled binary base system, but still gives you the flexibility to compile third-party software via Slack builds.
And finally, they mention Linux from scratch, or LFS.
LFS is fascinating.
It is purely an educational project. You literally build the entire toolchain, compile the Linux kernel itself, and construct the OS from raw source code within a CRUD environment.
Just writing that sounds exhausting.
It is an incredible way to learn, but it is definitely not a practical distribution for deploying a web server or getting daily work done.
Okay, so looking at that spectrum, does Slackware hit the Goldilocks zone for systems education?
I would say so, yes.
Like, it doesn't force you to build the raw compiler from scratch like LFS, so you aren't completely reinventing the wheel, but it still forces you to manually wire the house before you can turn on the lights?
Goldilocks zone is an incredibly accurate assessment.
Yeah.
Yeah, it provides a stable, pre-compiled foundation, but strips away the graphical abstraction layers that kind of lie to the user about how the computer actually functions.
They really do hide a lot.
They do. So with Slackware, you develop an innate capability to diagnose and repair complex computing environments. When a service fails on a corporate server, a Slackware veteran doesn't blindly search for a graphical toggle switch.
They just know where to look?
Exactly. They know exactly which configuration file to inspect and which daemon to restart.
Okay, we've firmly established Slackware as the purest, hardcore manual foundation of computing. But this is where I have to bring up the promotional studio image we received with these source materials.
Oh, this is the best part.
Because if you look closely at the visual context of this image, a hilarious and really fascinating contradiction emerges.
The production environment shown in that image is certainly revealing.
It's this beautiful, high-end multimedia studio setup. There's a saxophone resting on the desk, a MIDI keyboard, a professional XLR microphone, and dual monitors displaying sheet music alongside a complex multi-track digital audio workstation.
A very serious creative space.
Very serious. But at the bottom of the image, there is a text overlay explicitly stating how this specific upcoming episode, the one praising the manual text-based purity of Slackware, was actually produced.
And what does it say?
It reads, produced using pop.os GNU Linux, GIMP, Shotcut, and Notebook LM.
It's so good.
I laughed out loud when I read it. Here's a production team creating a love letter to the oldest, most manual, text-centric operating system in existence, and they recorded it using pop.os.
Which is pretty funny.
Right. Because for context, Pop! OS is a modern, highly automated, incredibly user-friendly distribution designed to work perfectly out of the box with literally zero manual configuration.
If we connect this to the bigger picture, it actually isn't hypocrisy. No, it actually validates the central thesis of the source article. The text refers to Slackware as the foundation of the palette.
Okay, explain that.
Well, the argument is not that every creative professional should be manually resolving audio codec dependencies while trying to record a podcast or edit a video.
That would just ruin the creative flow.
Exactly. The argument is that learning systems the hard way, the Slackware way, gives you the deep architectural knowledge necessary to truly master automated systems.
Ah, so you learn to drive on a terrible manual transmission so that when you finally get behind the wheel of an automatic, you know exactly how the gears interact with the engine.
Exactly that. The production team using pop.os is the reward for understanding the foundation.
I love that.
Once you know how the underlying Unix-like environment functions, you know, how ALSA and pulse audio routes sound, how the display server renders windows, you can confidently deploy highly automated distributions like pop.os as incredibly efficient tools.
Because you aren't afraid of them breaking.
Right. If the automated audio routing suddenly breaks during a recording session, the Slackware veteran doesn't panic. They know exactly which underlying configuration file the graphical interface is failing to update, and they just fix it in seconds via the terminal.
That makes perfect sense. And interestingly, the source notes that Debian is the subject of their next episode, which perfectly follows this progression from a manual foundation to automated power usage.
It's a very logical progression.
So what does this all mean? We started by talking about the frustration of opaque computing. You know, staring at that spinning update wheel and feeling totally locked out of your own hardware.
A feeling we all know too well.
Yeah. And what we found in exploring Slackware isn't just an ancient, stubborn piece of legacy code. It's a philosophy. It is a conscious choice to value transparency, mechanical education, and rock-solid stability over instant, unearned convenience.
It's a commitment to treating the computer as a comprehensible machine rather than just like a magical appliance.
Yes. And even if you never actually sit down with a CF disk partition manager to install a text-based operating system, just knowing that technology can be this transparent fundamentally changes how you interact with your own devices.
It absolutely does.
You don't have to accept that your computer is a black box that you aren't allowed to understand. The underlying text files and mechanics are still there if you are willing to look past the graphical surface.
Which really leads to a critical realization about the current trajectory of our technology as a whole.
Oh, for sure.
Because we are hurtling toward a future where modern operating systems are not just automated, but where artificial intelligence is beginning to hide the underlying code entirely behind conversational chatbots and predictive algorithms.
It's just adding more and more abstraction.
Exactly. The layers of abstraction are multiplying rapidly. This raises an important question to leave you with.
Let's hear it.
As the digital world becomes almost entirely abstracted by AI, will stubbornly manual, transparent systems like Slackware eventually become the only remaining way for future generations to actually understand the digital infrastructure they live in?